So far, we've inspected the water walls and the superheaters and the reheaters. It's time now to inspect two more boiler components, the economizer and the bottom ash hopper. Economizers are affected by general boiler problems: overheating, support failure, excessive ash accumulation, and refractory failure. Since the economizer is a tube-type component, it's also subject to tube thinning and soot blower problems. Excessive ash accumulation is a particular problem in the economizer. Most economizer tubes have fins or gill rings that can become blocked with ash more easily than bare tubes. There's another problem. Economizers are subject to accumulations of unburned fuel. Now, this is a fire hazard and is potentially explosive. When checking for ash blockage in the economizer, be sure to see if the ash includes unburned fuel. The economizer should also be checked for erosion, corrosion, general surface deterioration, problems with old repairs, problems with construction welds, and evidence of leakage. Economizer tubes are especially prone to corrosion because the economizer area has the lowest temperatures of the components we've discussed, so condensation is more likely to form in the economizer. Condensation leads to corrosion, especially if the boiler fuel has sulfur in it. Corrosion often shows up in the row of tubes where the hot gases leave the economizer. Comparing the outlet row of tubes with that of the inlet row of tubes should give you some idea of how much corrosion has taken place throughout the economizer. To inspect the economizer, techniques are used that are similar to those for inspecting the superheater. Like the superheater, economizers have tubes packed so close together that it's difficult to see the tubes within the bundle. Inspection of the inside tubes is generally made by looking down the lanes between the tubes. And here too, closer inspection can be accomplished by using a long-handled inspection mirror. As a last resort, the tubes may be spread apart to provide access to the inside of the bundle. It's important to look at the inlet and the outlet row of tubes because they're accessible, and their condition will give you an idea about the condition of the inside tubes. Another component that requires inspection is the bottom ash hopper. Now, the bottom ash hopper must be examined for 5 problems that affect the refractory inside the ash hopper. These are the effects of rapid temperature change, ash buildup, erosion, surface deterioration, and problems in previously repaired areas. The bottom ash hopper can have refractory problems caused by the bottom ash that collects there. The ash is very hot when it enters the hopper. Normally, it is cooled quickly by water in the hopper. However, this water must be drained every once in a while to get rid of the accumulated ash. While the hopper is empty, hot ash can heat the refractory on the inside of the hopper. This problem is made worse by the sudden temperature change that occurs when the ash hopper is refilled with water. The combination of heating and then sudden cooling of the ash hopper can lead to spalling and cracking of the refractory. Ash buildup is another problem in the bottom ash hopper. All bottom ash should be removed from the hopper when it is drained. Some ash may remain in the hopper if the spray nozzles are misaligned. If some ash does remain in the hopper, note it during inspection. The remaining ash will have to be removed manually. Early detection and correction of a problem within the ash hopper will avoid repeated manual ash removal. Another problem that can show up in the ash hopper is erosion of the refractory. Anytime water flows over refractory, there's the possibility of erosion. Be sure to check the general surface condition of all of the refractory inside the ash hopper. Things to look for include spalling, cracking, and erosion. Also, if you can see refractory anchoring devices at the refractory surface, the refractory is either badly worn away or was improperly installed. Previously repaired areas must also be checked when inspecting the ash hopper. Refractory breakdown in the bottom ash hopper is a fairly common occurrence. An ash hopper's refractory may be repaired many times, so inspect the refractory to make sure it's holding up. 4 more areas in the ash hopper are concerns during an inspection: the boiler bottom seal, the ash spray pipes and nozzles, the ash gate, and the ash hopper inspection doors. There are only general areas in the ash hopper, the ones that I've mentioned here, so some boilers will have even more places that require inspection. The boiler bottom seal is a seal between the boiler and the ash hopper. The boiler bottom seal isolates the furnace from its surroundings. 2 typical seal types are the corrugated seal and the sliding seal. The corrugated seal type allows the boiler wall to expand. The corrugated seal is accordion-like, an accordion made of corrosion-resistant steel. The sliding seal type is an overlapping metal joint which allows the boiler wall to expand. This type of seal uses water to prevent any flow of gas into or out of the boiler. Boiler bottom seals should be inspected for the 5 basic common problems we discussed earlier: overheating, ash buildup, erosion, general surface deterioration, and problems with old repairs. In addition, the metal parts of the seal may be corroded. Your inspection should verify that the seal between the ash hopper and the boiler is tight. Also, there must be nothing to prevent the expansion of the water wall. If you have any question regarding how your boiler's bottom seal works, consult your boiler manufacturer's instruction book. Most ash hoppers use pressurized water to stir up the bottom ash being removed from the boiler. This helps get all of the ash out of the boiler. Pipes and nozzles are used to direct the water spray. You must inspect these pipes and spray nozzles for ash blockage and misalignment caused by clinkers falling on them. The nozzles are aligned correctly if they direct their spray towards the ash gate, that is, where the ash leaves the boiler. And the nozzles should not spray directly at the refractory. That'll wear it away. The bottom ash hopper's ash gate should be inspected for proper operation by opening and closing it several times. The ash gate is underwater most of the time, so it has its own seals to prevent leakage. When you inspect the ash gates, these seals should be checked for any signs of leakage. These include corrosion, nicks, tears, burn spots, and torn gaskets. Like the ash gate, some of the ash hopper inspection doors are usually underwater. These must also be examined for leakage. All the inspection doors should be checked to verify that they're in good working order. Well, we've now discussed inspections of the boiler's economizer and ash hopper area. You've seen some of the potential problems. You should have a pretty good idea of what to look for when inspecting the inside of a boiler. When your inspection is finished, there's one final procedure you must never forget. Be absolutely sure that no one is left inside the boiler. Now, this may sound obvious, but it's truly a matter of life and death. Be positive that no one is left inside that boiler after inspection. Also, before putting the boiler back into normal operation, clear away scaffolding, tools, rags, anything else you may have brought inside. In short, after inside inspection, empty the boiler of everything: people, equipment, trash. Now, that's the last step for inspection inside the boiler. Still to come is the inspection of the outside of the boiler, which we'll discuss after you take some time to go over all of this material in your text. So far, we've been inspecting the inside of the boiler. However, the exterior of the boiler requires inspection too. Outside inspection means the boiler casing and dead air spaces where headers are located. Before you begin the inspection, talk to the operators. Find out if they know any of the problems with the boiler casing, problems like leaks, hot spots, or blistered paint. Operators can save you time and trouble, so don't hesitate to ask them questions about the boiler. The boiler casing, which is the outer steel skin of the boiler, is subject to those 5 common problems we keep seeing throughout the boiler: overheating, support failure, corrosion, problems in areas of prior repairs, and problems with construction welds. Some signs of overheating are burned or blistered paint. In fact, the casing may even get red hot. Overheating of the boiler casing leads to buckling, and this is caused by expansion of the casing metal. You can detect buckling by bulges and cracks in the boiler casing. Casing buckling can cause problems inside the boiler, so look closely at the inside components in the area where buckling takes place. The casing is hung at the top, so many of its supports are located there. To determine if there is casing support failure, look for broken or loose hangers, loose attachment bolts or pins, broken attachment lugs, and failure of any of the steel columns or beams from which the boiler is hung. Corrosion of the boiler casing can be caused by moisture, and it's a problem that can show up anywhere. Indications of corrosion are discoloration, roughness, and holes in the casing metal. Unpainted steel is particularly susceptible to corrosion attack. A previously repaired area in the boiler casing may not only be the source of current problems, but also indicates a previous casing problem. It's a good idea to inspect any previously repaired areas to verify that the repair work is holding up and that there have been no reoccurrences. Always check the construction welds in the boiler casing. Casings are constructed from large steel plates that are welded together, and the welds should not be cracked or corroded. There are still 4 more areas we need to discuss in connection with inspection of the boiler casing and its external features. These are casing stiffeners, casing penetrations, the boiler drum, if there is one, and safety valves. Casing stiffeners are projections from the casing that have been installed to give the casing added strength. They look like big fins welded to the casing. These welds should be examined for cracks and corrosion. Casing stiffeners are also good indicators of buckling. If the casing buckles, the stiffeners will bend. Bent stiffeners may be easier to see than bulges in the casings. Casing penetrations are the places where pipes or tubes go through the boiler casing. These are weak areas of the boiler, and failures can start here. Also, thermal expansion may press the pipe running through the boiler casing against the casing itself. This can damage the casing and the pipe. A hole in the casing can lead to corrosion. While inspecting the boiler casing, you should also inspect the exposed parts of the boiler drum or moisture separator. When inspecting either one of these, look for signs of corrosion and cracking where the metal is exposed. Check the welds on all the pipes and tubes attached to them for cracking and evidence of leakage. Verify that the insulation is intact and that it has not been damaged by water. Take a look at the safety valves. They can be inspected when the casing inspection is done. A complete safety valve inspection requires the valve to be disassembled, but that's not the kind of inspection we're talking about. Talk about that inspection another time. Here, we want to check 2 things: that the hand releases are installed and that the valves are not gagged. The gag, placed here, is a device that keeps the safety valve from opening. When installed, it prevents the safety valve's function of relieving pressure. Well, that covers inspection of the boiler casing. Now, let's talk about inspecting dead air space. Dead air spaces are enclosed areas outside the hot gas passages where the headers are located. These headers are your primary concern when inspecting dead air spaces. There are several common problems associated with the headers. We cover 6 of them: support failure, evidence of leakage, corrosion, cracks, problems in areas previously repaired, and problems with construction welds. Pay particular attention to the header supports when you inspect the upper headers. These supports hold up part of the boiler, so check the headers to make sure they appear level and in proper position. When incorrect, these are both indications of support failure. Watch for broken or loose hangers, loose attachment bolts, loose pins or straps, and broken attachment lugs. Evidence of leakage at the headers will show up as moisture deposits and discoloration of the header metal. Leaks are especially likely at places where tubes are joined to the header. Other likely leakage areas are those with other attachments to the header. Those include vents, drains, and safety valves. You should check the handhold plates for leakage. Corrosion can also be a sign of leakage. However, keep in mind that corrosion is a problem all by itself. Check for corrosion in the same places you check the leaks. Corrosion can be detected by discoloration of the header metal. Cracks in the headers are something else you must watch for. Look for cracks in both the header metal and in the welds in the headers. Check all the welds, both the weld repairs in the header and the construction welds. While you're checking them for cracks, also look for corrosion. Well, that completes our talk on the problems you might run into on the outside of the boiler. The casing is subject to overheating, support failure, corrosion, problems in areas of prior repairs, and problems with construction welds. Also, we've covered the types of problems you're likely to see in casing stiffeners, at casing penetrations, in the boiler drum, and in the safety valves. Remember, each plant is different. Yours may have particular problems that must be checked. Also, always talk to your operators and refer to your plant's instruction and safety manuals. You must clear up any doubts you may have before you start work on a boiler. Well, there are lots of potential problems to watch for while working on or around a boiler, so review all of the material in your text and take care of any questions or problems you might have. Be sure you understand all of the material, because knowing what to look for and where to look for it is what a thorough fireside inspection is all about.